All right, today we are talking about something kind of mind-blowing. Get this. It's a power source made from nuclear waste, and it's designed to last for thousands of years.
So, let's just jump right in with a huge question, right? Could a battery actually outlive our entire civilization? I know, it sounds like total sci-fi, but believe it or not, it's a real possibility with the tech we're going to break down today.
And just look at the scale we're talking about here. It's just wild. You know how your phone battery starts to get weak after, what, 2 years? And even a critical device like a pacemaker only lasts about 10 years before you need another risky surgery? This diamond battery, it's on a whole other level. We're talking a half-life of over 5,700 years. Yeah, that means it would take almost 6 millennia for it to lose just half its power. Insane. So how in the world is that even possible? Well, it all comes down to tapping into one of the most basic forces in the universe, atomic decay. So let's break down how it actually turns some pretty heavy nuclear physics into clean, quiet, and basically eternal electricity. Okay, the science behind it is called beta voltaics, and honestly, the easiest way to wrap your head around it is to think of it like solar power's lesser-known cousin. You know how a solar panel grabs sunlight, photons, and makes electricity? Well, a beta voltaic cell does the exact same thing, but instead of photons, it's catching something called beta particles. These are basically just high-speed electrons that get shot out when a radioactive atom decays. So here's how it works. It's really elegant. Step 1, you've got this radioactive stuff called carbon-14, and it's sealed up super safely inside the battery. As it naturally decays, poof, it shoots out a beta particle. Step 2, that little particle then flies into a special man-made diamond. And this diamond is the real magic here. It's not just a semiconductor, it's also the safety shield. It stops all the radiation, so the outside of the battery is totally safe to handle. When the particle hits the diamond, it generates a tiny electric current. And step 3, well, that process just keeps happening, over and over and over again for millennia, creating this constant, tiny trickle of power. But honestly, this is where the story gets really cool. The smartest thing about this battery isn't just how long it lasts, it's where the fuel comes from. Okay, so you know when they shut down old nuclear power plants? They're left with tons and tons of these big graphite blocks that are, well, radioactive. This stuff is contaminated with that same carbon-14. It's officially hazardous nuclear waste, and figuring out how to store it safely for, hundreds of years is a huge, expensive headache for countries all over the world. But this is the genius part. This technology takes that problem and flips it completely. Scientists have figured out how to pull the carbon-14 out of that nasty waste and lock it away inside these super strong synthetic diamonds. So what was once a dangerous, expensive problem becomes a safe, valuable power source. It's a perfect win-win. You just don't see that very often. All right, so what could we actually use these for? Let's get one thing straight right away. You are not going to be charging your phone with this thing. No way. The power output is way, way too low. Instead, think of it as a solution for very specific jobs. Places where you need just a little bit of power but you need it to last forever. Places where swapping out a battery is either a huge pain, super dangerous, or just flat out impossible. I'm talking about things like medical implants, right? Pacemakers that could last a person's entire life. Or powering sensors on space probes that are heading out into deep space, way beyond our reach. Or imagine sensors at the bottom of the ocean, or way up in the Arctic. You could just leave them there and they'd keep sending back data for hundreds of years. No maintenance needed. Let's really bring this home with a pacemaker example. A person gets a pacemaker, and then every 10 years, like clockwork, they have to go back for another surgery. It's invasive, it's risky, and it's just to change the battery. Now imagine a world where you just don't have to do that. One surgery, one time, the battery outlives the person. That's not just an improvement, that is life-changing.
Okay, but this all sounds a little too perfect, right? And yeah, we need to be realistic. Before these diamond batteries are everywhere, there are some pretty big roadblocks to get past.
And the biggest one by far is the power gap. Your phone needs a few watts of power to charge up. This battery? It produces microwatts. We're talking millions of a watt. It's an incredibly small trickle of electricity. So its superpower is lasting forever, not being powerful. And that really, really limits its applications. And beyond that low power, there are other big challenges. First up, cost. Making these special diamonds and getting the carbon-14 out of the nuclear waste, it's super expensive right now. Then there's all the red tape. You're dealing with radioactive material, so you have to jump through a ton of hoops with regulators. And finally, you've got the PR problem. You have to convince people that a nuclear battery is safe. Even if it is, that name alone is going to scare some people. That's a huge hurdle to overcome.
So let's put this into perspective with other long-life batteries. You can see it's way, way safer than the plutonium batteries we use on space probes like Voyager, but it also has way, way less power. And as for lifespan, well, it's not even on the same planet as the best chemical batteries we have. It really has its own special little niche.
You know, when you zoom out, this is about more than just a new kind of battery. It's a whole new way of thinking about technology. We live in this world of planned obsolescence, right? Where your phone is designed to be replaced in a few years. This thing is the complete opposite. It's all about endurance, not just raw power. And it points to a future where we could take our most dangerous waste and turn it into something that lasts for generations. A legacy.
So I'll leave you with this question to chew on. In a world obsessed with speed and power, what if the best innovation is one that simply refuses to stop? It really makes you think about technology and time itself in a whole new way, doesn't it?